Okay, in this video we're going through the chord of a circle theorem. So before we understand this, we need to understand what a chord is, and basically that's when you take a line from the circumference out to the other bit of the circumference and it's a straight line that goes from there to there. That's called a chord. Turns out that if you have a chord which happens to pass through the center of the circle, that chord has a very special name and it's called the diameter of the circle. Alright, let's look at our theorem. So this is the theorem here. And it's very wordy, but it says perpendicular from the center to a chord bisects the chord. Let's break down what each of these words mean. So this thing here says 90 degrees, that's what perpendicular means. And we're talking about going from the center to the chord. So what we're doing is we're saying I'm taking a line from the center of the circle to the chord, and I'm going to make sure that line is at 90 degrees to the chord. If I do that, it's going to bisect the chord. Now, bi means two. Sect means cut. So this line is going to cut the chord into two equal pieces, and that's why they've drawn these links on here. So let's step out exactly what this theorem means. If I take a line from the center to a chord, and I make sure that line hits the chord at a right angle, that line will cut the chord into two equally sized pieces. And that's what they mean by AM equals BM up here. All right, so this theorem comes along with a few corollaries. First one, converse one is the line from a center to a midpoint is perpendicular. So this is going the other way to our theorem. So it says, if I take a line from the center to a chord and I make sure that line cuts the chord in half, then that angle has to be a right angle. So the original theorem says if the angle is a right angle, it cuts it in half. This corollary says if it cuts it in half, then that has to be a right angle. So it works both ways. All right, next is perpendicular bisector of a chord passes through the circle's center. So basically this one says if I have a chord here and I draw a line out and that's at right angles and it cuts that in half, this converse guarantees that it goes through the center of the circle. Cool stuff. All right, let's do an example. So this one here, it says PQ is 12 and we want to find the length of PA. So when they say PQ is 12, they mean this whole length here is 12 centimeters, and they're looking for PA, which is this length here. Given that our theorem says it cuts this in half, this should be 6 centimeters. But what we're going to do is step it through bit by bit and make sure we do this very formally. So let's start by saying PA equals AQ because of the chord of a circle theorem. Great. So this little symbol here means because, and chord of a circle theorem is the theorem we just learnt. And I'm saying PA equals AQ. So basically what I'm saying is that I've just drawn in these little lines to say they're the same length. Great. Next, we're going to step it out. So PA plus AQ equals PQ, and this is given. And what I'm basically saying there is, well, if I take the two bits PA and AQ and I add them together, I'm going to get the whole length, which is PQ. PA plus AQ equals 12. This is also given. So basically what I'm just doing is I'm saying PQ is 12, which the question literally says. And then we're going to do PA plus PA equals 12. So basically replacing AQ with PA because I know that it's supposed to be the same length. So PA is 6. 6 plus 6 would give me 12. This is in centimeters as well. So that's how you'd step it out formally. Next question we're going to do gets a bit more tricky, but each individual step is hopefully approachable. So we're going to put in immediately what we know, and that's that PQ equals 1 on this. And we're going to be looking for the length R to S, which is like this whole length here. We've got a few steps to make it there. So really importantly, the diameter is 10. So let's use that to fill in all the bits and pieces that we want to know. So if the diameter is 10, we can immediately say, well, that length there is the radius. So that has to be 5 centimeters. Also, the other side is the radius. So that whole thing has to be 5 as well. But realistically, that means that this bit is 4 centimeters. So let's fill in what we know. PO or OP is 4 centimeters because diameter is 10 centimeters, and we already know that PQ equals 1 centimeter. Great. So that's good news. The other thing we're going to do is draw a line from O out to R. We'll see why shortly. But this line also has to be 5 centimeters because that's a radius. OR equals 5 centimeters because OR is a radius. And we know the diameter is 10, so the radius has to be 5. Great. So now let's break off this triangle that we're looking at. The triangle we're looking at here is a right angle triangle. And it's got R up the top, O and P. So the triangle I'm trying to look at is like that triangle in there. All right. So we know a few lengths here. That's 5 centimeters and that's 4 centimeters. We don't know what this length are, but we're going to figure it out very soon. Now, some alarm bells might be ringing for you, and this may remind you of something called Pythagoras. So let's label our triangle ABC. And Pythagoras tells us that a squared plus b squared equals c squared. We know what these things are. So b is 4, c is 5, and a we don't know yet. So a squared plus 16 equals 25 is what we end up getting once we simplify it. And then, well, let's take 16 from both sides. So we're going to get a squared equals 9, and that tells us that a is going to be 3. I mean, technically it could be minus 3 as well, and this is a weird thing with squared numbers. So if I took minus 3 and squared it, I would get 9. So minus 3 is technically an answer here, but since we're talking about lengths, lengths cannot be negative. So as lengths are positive. So yeah, we'll learn more about this in quadratics soon, but when you take a square root, it has to be the plus version or the minus version, because 3 squared would give you 9, but minus 3 squared would also give you 9. But since it's a geometry problem, that's a positive number we're looking for. A is 3. Let's draw it on our diagram, 3 centimeters there. So basically, you'll hopefully see the whole thing here is 6 now, but let's step it out formally. So our PR is 3 centimeters. Because Pythagoras on triangle ORP. And then, therefore, RS equals 6 centimeters. And this is because of the theorem that we've been looking at here, the chord of a circle theorem. Great. So the whole length is 6, and we are done because that's what the question asked for.